everyone. You're most welcome to our Electro Oracle project. So we are going to do this project. It's our machine learning project. Previously in our series, we had shared about what we learned in our short machine learning course that we did. So that was individual, but now here I am working on a project with my colleague Nsubuga Ibrahim, and I am Nakalema Julian. Our project is Electro Oracle, that is electronic waste prediction and management. We are looking at how to predict whether an electronic device is still important for use or it is ready for recycling or disposal. The contents of this presentation, we have the introduction, problem statement, objectives, research, contributions, data set, and EDA methodology, that is the exploratory data analysis. Now, this is going to be a project, but we are going to take it step by step. So, our first step was the exploratory data analysis, that is understanding the data set that we are dealing with, and it is what we are sharing with. And as you keep on with us, you will know the progress of our project. Now, the Electro Oracle project, it focuses on data-driven analysis of electronic device life cycle and depreciation patterns in order to support early identification of devices that are likely to become electronic waste and dangerous to their users. So we are looking at the project, it is looking at how are we able to detect that this device is about to become electronic waste. How are we able to detect that it is now ready for disposal? Yes. Now our problem statement, determining when electronic devices should transition from active use to recycling or disposal is a complex decision, and it is influenced by multiple factors. And the factors that we are using in this case are the features in our dataset, as we shall be seeing. So from a conceptual computational perspective, the problem can be framed as a predictive modeling task using structured data describing electronic devices and their life cycle characteristics. So this project, we have two major problems, that is the regression problem and the classification problem. The regression problem, here we're looking at the relationship between the device characteristics and its current price to know whether it has depreciated, how has it depreciated. Then the classification problem, we identify whether a device can be considered e-waste ready based on the life cycle indicators. Our objectives. Now we have the main objective and the sub-objectives. Our main objective is to analyze patterns of depreciation and usage to estimate whether a device is approaching the end of its useful life using the different features. So we are going to, our main objective we're saying is our device approaching the end of its useful state, and we shall use the different features. That's, we had the build quality, the brand, we had the usage patterns, etc. So our sub-objectives. In our sub-objectives, with this video, we are going to look at the first three sub-objectives because we are only doing exploratory data analysis of the data set as of now. So now our first sub-objective is to examine the structure and quality of the data set by identifying data types. We need to check for missing values. So we are looking to see what is the quality of our data set. Is it good quality or bad? And you know, when we have bad quality data set, it affects our performance. To perform exploratory data analysis, in order to understand the statistical distribution and relationships among the different variables. So we need to understand how are these variables related, how does one affect the other. So we do that through exploratory data analysis. Then we need to analyze the depreciation patterns of electronic devices by comparing original price and current resale price across different product types, usage patterns, and device conditions. Then now this is our data set and exploratory data methodology. So we had our data set consists of 10 features, and in these 10 features we had 15,000 inputs. The features, we have the build quality, user lifespan, expiry years, etc. I'll be explaining more on these features, what they mean as we proceed. So we had also the different data types. We had string data types, we had integers, floats, and So data integrity and quality assurance. Here we are looking at how good is our data set. Now with our exploratory data analysis, we realize that we actually have no missing value and we have no duplicate values. So when we looked at completeness, it was a tick, and when we look at uniqueness, it was a tick. Then we have the feature description. What is the meaning of these features? Product type. When you look at product type, you're looking at what kind of product is this? Is it a phone? Is it a TV? Is it a refrigerator? Then we come to the brand, we look at the make. For example, I'll give the brand, clear brand will come out when I use cars. For example, with cars, we have the Toyota, we have the Benz, we have the Mitsubishi, etc. Then we come to build quality. What is the quality of the materials used to make these devices? So we have from 1 to 5, with 5 being the best and 1 being low quality. Then user lifespan. As a user, when you're buying this device, how long do you expect to use it? Then we have the usage pattern, that is light, moderate, heavy. That is evident in phones. Realize sometimes the phone can tell you that, oh, today you used your phone too much. Expiry years. Now, expiry years is a technical decision made. So that the technical team will sit down and be like, basing on this electronic device, within a period of maybe 6 years, it will be dangerous to use. For example, with refrigerators, when it is in good condition and they say maybe past 10 years it's in poor condition, yes, you may use it by force, but at that time it's releasing a dangerous gas which makes it ready for disposal. Condition, what is its current state? So that is also from 1 to 5, 5 being good state, 1 being in the worst state. Original price, what was its initial resale price? What was its, how, when it had just been produced, how much were they selling it? With the use duration, for how long has it been in use? Then with current price, after some time, what are we selling it at? For example, some phones, when they come out, they are at 4 million, and then after some period of years, you find the same phone at 500,000. So what led to that? So the exploratory data analysis methodology. I will invite my colleague to proceed from there. Thank you.
My name is Suga Ibrahim, and I'm going to be taking you through the actual EDA methodology. So the EDA was conducted to understand the structure, distributions, and relationships present within the dataset. And the goal of this analysis was to uncover patterns in device depreciation and user behavior that may influence the current resale value of the electronic devices. So the dataset contains structured information describing electronics and appliances, including product type, brand, usage patterns, expected lifespan, build quality, etc. So these attributes collectively represent the life cycle and value dynamics of consumer electronic products. So first, now EDA, we had distribution of variables. So we wanted to understand how key variables behave within the dataset. Univariate histogram visualizations were created for several numeric attributes. So examining the distribution of these variables provides insight into underlying characteristics of data and highlighting potential skewness or structural patterns. So next slide, we have first we studied the current price distribution, and distribution of the current price is highly right skewed, indicating that most devices fall within the lower price ranges, while a small number of devices retain significantly higher resale values. So the median value of the distribution is substantially lower than the maximum price observed, demonstrating a long upper tail. So the next one was original price distribution, and similarly, the original price variable also exhibits a right skewed distribution, and this indicates that majority of the products were originally purchased within low to mid price ranges, while fewer high-end devices exist in the dataset. This pattern is typical in consumer electronics markets, where affordable devices dominate the market, while premium devices represent a smaller segment. So the next, we have used duration distribution, and the other condition distribution, and third, we have the build quality distribution. So as you can see from the visualizations, the behavior, they demonstrate the distributions are relatively uniform, and this behavior is expected because these variables are discretely defined and appear to have been intentionally balanced across the possible values. So such distributions helps ensure that each level of these attributes is sufficiently represented in the dataset, which can improve the robustness of later modeling processes. So the next one, we had expiry years distribution, and in contrast, the expiry years variable displays multimodal characteristics, meaning that multiple peaks appear within its distribution. So this behavior suggests that different categories of products have different expected lifespans. For instance, large household appliances may have longer expected lifespans compared to smaller consumer electronics such as smartphones. So the next one, we had patterns and relationships. So to better understand how the variables interact with each other, a correlation analysis was performed on the numerical features within the dataset. So the primary focus on the analysis was to determine how strongly different variables relate to the current price, which serves as the main outcome variable in the study. So first, we have the correlation heat map, and the, the analysis revealed that the original price had a moderate positive correlation with the current price. This indicates that products with higher original prices generally tend to retain higher resale values. Although depreciation occurs over time, the initial price still plays an important role in determining the remaining value of a device. So another important relationship was with use duration, which was a strong negative correlation with current price. So this suggests that as the duration of the usage increases, the resale value of a device decreases significantly. This pattern aligns with the expected behavior of electronic products as where technological obsolescence and performance degradation reduce their market value over time. So other variables demonstrate weaker but still meaningful relationships with current price, for example, expiry years and user lifespan. So overall, the correlation analysis highlights that usage duration, original purchase price, and expected device lifespan are key drivers of the resale value. So next, we wanted to study the segment level pattern discovery. So beyond the numerical correlations, the dataset was further explored through segment level analysis to identify patterns across different categories such as product type, usage pattern, and device condition. So when analyzing median current price across product categories, several product types stand out with significantly higher resale values. So we can see that televisions, refrigerators, DSLR cameras show the highest median resale prices. So next we had the usage pattern analysis. Devices were also analyzed according to their usage patterns, categorized as heavy, moderate, or light usage. So interestingly, the average current price appears relatively similar across these categories, and additionally, the average use duration does not vary significantly among these groups, as you can see from the visualization. So next, we had the condition analysis, and device condition demonstrates a strong and intuitive relationship with resale value. The median current price increases steadily as the condition rating improves from level 1 to level 5. So devices rated with condition level 1 have a median price of approximately around 2,500, whereas devices rated at condition 5 reach a median of approximately 6,000. So 6,800, 6,800 roughly. So this monotonic increase confirms that condition is an important indicator of quality and plays a significant role in determining resale value. So next we had the outlier and anomaly analysis. So to identify potential anomalies in the dataset, outlier detection was performed using the interquartile range method. So this approach defines outliers as observations that fall significantly outside the typical range of values for a given variable. So the IQR rule was applied to several key numeric attributes, including original price, current price, use duration, and expiry years. So the analysis revealed that around 1432 rows, representing approximately 9.5% of the dataset, were flagged as outliers in at least one of these columns. So the presence of outliers is expected in price-related datasets because consumer electronic markets often include a wide range of product tiers. So from low-cost devices to premium higher-end equipment, these price extremes naturally produce heavily tailed distributions. So next we went on to the conclusion lastly, and the overall exploratory analysis reveals several important characteristics of the dataset. The dataset exhibits a well-structured schema with both categorical and numerical attributes that describe device characteristics, usage patterns, and pricing behavior. Data quality appears strong with no missing values or duplicate records, and the distribution analysis shows that price variables are strongly right-skewed, indicating that most devices cluster in lower price ranges with a smaller number, while a small number retain high resale values. So the correlation analysis demonstrates that the current resale price is strongly influenced by original purchase price and usage duration, while others, such as conditional and expected lifespan, provide additional explanatory power. So finally, the dataset contains a moderate proportion of outliers and lifecycle anomalies, which reflect the natural variability present in the electronic device market.
Thank you for listening and keep up with us to the next step of our project. Thank you.